So recall, how do you find the inverse of a function algebraically? You did this on day 1. So the very first step when you do this is you're going to, 1, switch the x and y. That was what we learned on day 1. We switched the x and y. And then 2, we solved for y. Solve for y. And that's the same exact thing we're going to do today, but now they're going to be more challenging problems compared to the ones that we did on day 1. So again, you practice this day 1. You've already done the easier versions, and now we're just going to try to talk about more advanced ones. Okay? So find the inverse of each function algebraically. So the very first step, like I said, so step 1, is that we're going to switch the x and the y. This y will become an x, because remember, that's technically a y. That's really what that is, but it's just function notation. Is equal to parentheses 5, now y, because we switched them, plus 2, oop, that's supposed to be black, plus 2 cubed minus 4. So that was literally the first step. That's all we did. We just made the x a y and the y an x. Now again, the goal is to solve for y, not for x, for y. So this is going to be step 2. We have to solve for our y value. What would you do first to move everything to the left side? What would you think that you would move first? Would you move the 5, the 2, or the 4? Which one do you think you would move? The 4. Because this guy is all together. Like, he's like one thing. So we have to move him first. So we're going to add 4 to both sides. So I'm going to add 4, add 4. Now remember, that 4 does not add to the x. So I have x plus 4 is equal to 5y plus 2 all to the 3rd power. I'm going to take it slow on these ones just so that we get used to it. And I'm going to write all the steps down until, again, you get used to it. Then you can decide if you want to skip steps or not. Okay. Now, again, we're solving for y. He's like inside this parentheses. We got to get him out. We got to get him alone. Okay. He wants to be by himself. In order to get rid of a cubed, you have to do the inverse. Does anyone know the opposite or the inverse of cubing something? What'd you say? Square is the same thing as cubing. It's the same operation. So we kind of talked about this a little bit ago, but yeah, square root, but not square root. You cube root it. But that's very good that you said that. So I'm going to write off to the side maybe somewhere, like I don't care where you put it, but the inverse of x squared is square rooting. The inverse of cubing something is cube rooting is what it's called. Okay, so to get rid of a cubed, you must cube root it. That's the inverse operation. That's the opposite. So once you have that written down, I will make sure that we do that operation. Okay, so I'm going to, with a different color here so you can see, on both sides cube root. Just like we did when we moved the 4. We had to add 4 to both sides. Just because it's weird and you haven't done things like this in the past doesn't mean that you can't do it. We just have to, so that these cancel, that's the goal. Just like these two canceled, these are going to cancel because they're opposites. So now I just have the cube root of x plus 4 still inside is equal to 5y plus 2. And now it's going to be a little bit easier. I think that's the hardest step. Because again, we're solving for y. So would I move the 5 or the 2 to the left side? Which one would you say we would move first, the 5 or the 2, when you solve something? Yeah, I heard someone say 2, and you're correct. So we're going to subtract the 2, subtract 2, subtract 2, gone. Again, it looks weird, guys, and I get that, but it's just undoing everything is what you're doing. Then minus 2. You can't do 4 minus 2. That guy is inside a radical. This one's outside. Is equal to 5y. Now, what would you do next? Because again, you want y alone. Divide by 5. So it's never, don't really ever think about like what's on the left side. Who cares what's on the left side? It's just how do I get everything from the right side to the left is really what you're doing. So I'm dividing by 5, and we're going to be done. It looks weird, but that technically is your answer. So remember when we did these problems, we always ended with this notation. Again, it wouldn't be the end of the world if you didn't. If you ended with y, I would accept it. It's just not 100% accurate. But then everything else is the same. Just rewrite it. X plus 4 minus 2 all over 5. Again, it looks weird, but again, you have to know what you're doing here. The inverses, if you're trying to find the inverse function, you just undo everything. I undid the 4. Then I undid the cube, then I undid the 2, then I undid the 5. Like, I just moved everything. So remember, like, put your finger on y and say, I must move the 4. I must move the cube. I must move the 2. I must move the 5. It's just what operation are you doing to move them is really all you're doing. It's like reordering is really the only thing you're doing here. That was a little bit of a tougher one. Let's do another one to practice here. This one's a lot easier, I promise. Okay, the first step is to switch the x and the y. Remember, this is technically a y. So here I have x instead is equal to 3/2. Now y, because again, that's the only thing that changed, plus 7. Good there. Now again, if I point to this y, that means that this 7 must move and the 3/2 needs to move. Okay, so just knowing that before you start. What would I move first, the 3/2 or the 7? The 7. And in order to get rid of the 7, I must subtract 7 to both sides. So I'm going to subtract 7, that goes away, and subtract 7. Now remember, you can't add those, they're separate. So I have x minus 7 is equal to 3/2 y. And we're really close to being done, that's why I like this one. This one's a kind of you've learned it. I just want to see if you remember it, if anyone does. How do I get rid of 3/2? What do I got to do to get rid of 3/2? Multiply by what? You're right. By something over something. Not 1/2. How would you get rid of 3/2? Like, let's think about this like mathematically, just to get like a problem-solving process down. In order to get rid of a 2 on the bottom, I must have a what on top? A 2, right? Okay, because they have to cross out. In order to get rid of a 3 on the top, I must have a 3 on the bottom, right? So really, to get rid of a fraction, you just flip it. Okay, and you must do that to both sides. Because now watch, gone, 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 gone. That's the goal. Think of it that way. In order for me to get rid of a 3 on top, I must have a 3 on the bottom. In order for me to get rid of a 2 on the bottom, I must have a 2 on top. Okay, so I get y is equal to 2/3 times x minus 7. And that's okay. Just put that in parentheses and I'm happy. Because remember, the 2/3 goes to both of them. And we're done. I'm gonna change the notation. Inverse is equal to 2/3 x minus 7. All I did right here is I changed that, because that technically is what you would see on a multiple choice. You wouldn't see y equals, you would see the inverse of f of x on there. Do you have questions on that one? And just taking your time. As long as you know how to undo every operation, you're going to be fine in this chapter. Okay, this one. Here we go again. First step. Switch the x and y. This becomes an x. And I'm going to rewrite everything, but instead of having an x here, I'm going to have a y plus 5 plus 1. There is no way to do this in your head, guys. So you need to make sure that you're showing work and trying it. I mean, I guess there's a way, but you would really have to understand like the whole process. And if you can show me, if you can tell me how you do it in your head, because I can tell you how to do it in the head, but if you can't, then just write it all out, please. Okay, now again, the goal is to get everything to the left side. What would you think we should move first? The 2, the 5, the 1? The 1. Okay, so I'm going to subtract 1 to both sides. And I get x plus 1 is equal to 2 cube root y plus 5. You're right. Minus 1. Thank you. That's why I got you guys to check me out. When you guys do this problem, the radical right here needs to be alone. It's like he's an x. It's like he's a variable. He needs to be by himself before we do anything. So what would you do with that 2 to get rid of the 2 on the right side? what would you have to do with that 2? You would divide it because it's currently multiplying. So 2, you have to divide. It goes away. So I get x minus 1 all over 2 is equal to the cube root of y plus 5. And we have 2 more steps. I have to now undo this cube. What is the inverse of cube rooting? We talked about that. Go back to like what I drew on the side. What's the inverse of cube rooting? Cube it. Yeah, it's the opposite. Cube it. So I'm going to cube it and cube it. Or raise it to the 3rd power if that helps. Whatever this is in here, you raise it to that power. If it was a 5, you would raise it to the 5th power to get rid of it. Okay, because now look, that goes away. And I am left with x minus 1 over 2, all to the 3rd power, is equal to y plus 5, because that's what's left inside. And we just have one more step, and we are done. Remember, y needs to be alone, and we're really close. That's why I love math sometimes, and it's not because of the equations and the solving. It's like the thought process, like the logic behind this is kind of cool, in my opinion. What do I do with this 5 to move him? Subtract it. So I subtract 5, gone, subtract 5. Now it looks weird, like how would I subtract 5 from there? But you're basically done. Let me just rewrite it. F to the negative 1 inverse, because that's always what we end with, is equal to x minus 1 over 2 all of the 3rd power minus 5. So that's the only thing there is I just changed it. When you subtract 5 to this whole group, you just write it, subtract 5. That's all you do. Now what's really cool about this is like if you really want to check your answers, you can undo it again and see if you get back to the starting point. I mean, that's really what you're doing. Do you have any questions? I know that was like it's a really big thought process is what this is. Like, what do I do? What do I move? Okay, what's the inverse operation? Just really try to like think in your head when you're doing these problems. I need to get everything besides the y on the left side. So I moved the 5, I moved the 2, I moved that radical, I moved everything to the left. All right, we're almost done. Okay? All right, let's talk about 9a. It says, sketch a graph of the function. So we have to first put a graph on paper of this guy, not the inverse of the original, it says. Then it just says, find its inverse algebraically, which is what we just did. And then we have to do the domain and range. So let's get out a graphing calculator. Get you guys used to doing that again. And let's go to y equals, clear it out. And let's type in what we have here. Sorry, I don't use keys, so I have to go back and look. X minus 2 cubed plus 3. So x minus 2, so parentheses, x minus 2 all to the 3rd power. Let me show you how to do that. You press that little arrow symbol in red. And then you press 3. And in order to get out of there, you have to go to the right. And then what was it after that? Plus 3? Does that look right? Okay, well, let's go ahead and graph it and see what we got here. So we went to y equals, and then we put that all in. Press graph. See what we got going on here. Okay, so we got this. We know the general shape of it. So we can either we can use this as our guide, or we can go to the table and get points, whatever one works for you. Okay, I like to try to get points in this area, because if you come over here, you really would kind of get stuck. But it doesn't matter what you choose though. You can go to second table, second graph, and you can get some points here. You obviously want to get ones that are small enough for you to use. So I'm going to come down here and get some points. Sorry, my computer calculator is a lot slower than your calculator is, so hold on. If I scroll down, I'm going to just get points that I know I can use. I'm not going to be able to plot negative 61. That's crazy. But I know I can plot negative 5 and 2. Okay, so I'm just going to go side by side here. You're going to have a calculator when you're doing this. So let's go ahead and graph it. It says I have 0, negative 5, so 1, 2, 3, 4, 5. It says I have 1, 2, so 1 up 2. It says I have 2 up 1, 2, 3. it says I have 3, 4, 1, 2, 3, up 1, 2, 3, 4. And that's really all I need because 11's too high. And again, I don't really care how you draw this as long as it like somewhat resembles what it looks like. Okay, so like just kind of connect those dots. If you went left to right, you can kind of connect just the way it looks here. If you want to be super accurate, great, but you need just to be able to get a couple points on that graph. Do you remember putting that in the graphing calculator? It wasn't too hard? Okay, now let's talk about a couple things. The next step, it says to find the algebraic graph. So this is what we did on the last page. Same question almost as the one on the last page. So let's switch x and y. Here, this is going to become x. This is going to become y, just like normal. Let's just keep practice doing this. We're undoing the y. The goal is to get y. So what does that mean? I must move the 3. I must do something with this guy. And I must move the 2. So there's 3 things I have to do here, even just counting how many items you need to do. So what am I gonna do to both sides first? -3, very good. You're killing it. So I have x minus 3 is equal to y minus 2 cubed. Again, I say it a million times. The goal isn't always to find an answer. It's to get your brain to think a different way. Now, again, we're undoing. Now we have to undo. Because remember, parentheses, like they're together. How do I undo to the 3rd power? What would I have to do to both sides? Square root it, but not square root it. It's cube root it. Or I don't even know how else to say it, but cube root is the only way that I know to say it. So it's called cube root. Now, if you had like a 4 there, the 4th root. If you had a 5 there, 5th root. If you had a million there, the millionth root is what you would take to undo it. Okay, so whatever that is, whatever this power is, you use this radical symbol with the index of 3 is what that's called. So that's gone. And I'm left with the cube root of x minus 3 is equal to y minus 2. Because this is still inside. The only thing that cancels is this 3 and the cube root. Because that's the goal. What's my last step here? You have to add the 2. Very good. So I add 2. And I'm just going to like put add 2 off all the way to the side so that you guys don't do 3 plus 2. Because that guy is like inside the radical. You can't do that. So I have this inverse. I always just like set myself up at this point. And I just rewrite it. Cube root of x minus 3 plus 2. And that is my answer there. So getting more practice with that. Questions? So this 2 did cancel, but he's over here now, like with this guy. Yeah, it's a really good question. I kind of skipped a step there by not writing y equals. So if it helps you, write out y equals cube root x minus 3 plus 2. And all I did then was change the notation. Again, I would accept this answer right here. I'd be very happy. However, like I always encourage you guys, do it as far as you can, which is all you have to do is change the notation from y to the inverse. Okay, last piece of this problem. So it's like putting everything together, and you guys are doing fantastic. What is the domain of this graph? What do you think? Yeah, negative to positive infinity. Here's my hint to you, and just like as a little math person I'm hoping you're becoming. If you ever have a power of 3 or a power of 5, anything odd, it'll be all real numbers every single time. Look at this next one. Square root is technically a 2 in there, right? When you take the square root of something, you're getting groups of 2. So that's going to be restricted somehow. But this one is odd, so you know it's going to be all real numbers for both of them, always. Now, you really won't see it here on this one, but the inverse, remember what we talked about on your homework on question number 1. The domain and the ranges will always switch. So yes, there's still going to be negative to positive, but you can figure out your domain and range of your inverse just by knowing your original. Again, odd power will result in this every time. Okay? All right, next one. Do you have questions on that one? I don't want to overdo it. Okay. I want to make sure we do this one, and then I think we can call it a day. I don't think we have to do that last one because I want to give you time for your homework. Okay, this next one. Okay, so the very first step is let's just get a graph on paper so that we have it. So let's go ahead and get to our graphing calculator. Go to y equals and clear it all out. That's how we do our graphing. Okay, now to get the square root is pretty straightforward. You just have to press that blue second button, and then there's that x squared button. You can kind of see it here. And here's what's pretty cool about your calculators, if you kind of just look at your buttons really quick. And I wish I can zoom mine in here. But they show you what the inverse of everything is if you take a look. X squared, the inverse is square root. Do you see how it's right above it? Yeah. Same thing with, we haven't gotten there yet, but like we're gonna get to these things called logs. The inverse is right here. Their inverses are like on top of each other, which is pretty cool. The people that developed a calculator did a nice job with that. Anyways, then we have x, and then what was it? X what? Minus 2. Okay, so minus 2. Let's go ahead and graph it and just see what it looks like. Kind of get a visual here. Now again, I'm not looking for like super accurate graphs.
Oh, wait, that's the second one, right?
Yeah, we're on the second one. X minus 2, right? Is that what it is, guys? Oh, it's x plus 2. Go back. Go back, go back, go back.
Square root
X plus 2. There you go. And press graph. So it moves over a little bit more. So this one, I'm not really looking for a lot of graphs. Like this one's easy to graph without like doing too much. This is the easiest one. Look, left, 1, 2, and then sketch it. I don't really care how you sketch it, as long as you get that 2 over. Okay, so let's go ahead and go here and go left 2, 1, 2. And then I don't care if you just sketch it like that. That makes me happy. These ones are a lot harder to graph just doing that. So just sketch it on out. If you want to be more accurate with yours, you're more than welcome to. But when I say sketch, you're fine. I will tell you if I want accurate points. Second step, switch the x and y. Here we go. So this is becoming a y. I lied. It's becoming an x. Equals a square root of now y plus 2. So that's the first step always, is just to change the x and the y. Are we okay there? Yeah. All right. So here, let's take a look. A lot of people, their first instinct will say subtract 2. However, you see how like they're inside of something. Like it's kind of like a parenthesis. Like it's inside the radical. So we have to get rid of the radical first. How do I get rid of square root? What's the inverse of square rooting something? Squaring. Okay? So here's my hint to you. Remember when you square root, there's technically a little 2 here. Technically. Remember, you always raise it to that power. So it's going to be to the power of 2 to the power of 2. So now look, gone. And I get x squared is equal to y plus 2. And I only have one more step. And now what do? How do I get y alone? What must I do? Minus 2. Very good. So I always set up at the very end, this little notation for myself, and this is where that's going to come in, because I have x squared minus 2. Now again, if you chose to write y equals x squared minus 2 first, that's fine. If you look, it's the same exact thing, except for I changed the notation, which I asked you to do in the past. Okay. Let's take a look here. What is the domain of this original? Because that's what f of x is the original. I have this to this. What is it? What number do I start with? Negative 2. So I have in pink here negative 2 to positive infinity. Let's talk about the range. Okay, from the range, where do I start? What y value is that? 0. Okay, so this is 0 for y equals 0 here. Oops. Y equals 0, and then here is that negative 2. So that's why it's going to be 0 to infinity. Now, remember, the x's, the domains and the ranges change. So this domain is going to become that domain of the inverse, or the range of the inverse. So -2 to infinity. And then this one is going to become that guy. That always happens. Always. And if you were to put this in your graphing calculator, it would prove it to you. Okay? I'm just going to show it to you. I'm not going to make you write anything. But I'm going to show you that this right here would get this. And it would look like this. That would be your inverse. Do you see how your domain now is 0?